Tire industry is highly manufactured. There are still many manual operations handling on quality control. It's an industry of processes, material transformation, and assembly. Digital manufacturing is a key lever to increase our industrial efficiency. When it comes to digital manufacturing, we are talking about a real revolution made possible by the emergence of high-performance technologies that automatically make data available to the right person, the right place, and at the right time. We already had some of this data, but we are now able to improve it and analyze it more than ever before, using more accurate and sophisticated measurement to make the best decisions. In addition to using this rich source of data, Industry 4.0 also relies on automation through the increased use of robotics or automated guided vehicles. So this deployment is progressing at a good pace and has been achievable thanks to two main prerequisites. The first is an efficient production system based on lean principles, the Michelin manufacturing way. Digital technologies give a further boost in performance to operations that are already well optimized. The second is the work on empowerment, what we have been done for many years in our production workshops. The autonomy given to our operational teams allows them to react more quickly and specifically based on the information received. Our autonomous performance and progress management approach is already a reality in many of our workshops. Thanks to our machine manufacturing way and empowerment, we create value through the extensive use of data and new technologies. The digital manufacturing program is based on an approach that balances top-down and bottom-up processes. This means that our plants undertake local projects called demonstrators and identify the most relevant and value-creating application for them. The central teams develop the technological and methodological framework, support the value-creating demonstrator projects to ensure they use our worldwide standards, and lead change management activities to drive deployment. This approach encourages adoption, user focus, and also ensures that the solutions are relevant. On the visual, you can see the different areas in which we have identified performance levers resulting from digital technologies. Each lever has several use cases. They allow us to better understand how our machines perform by automatically monitoring their utilization rate, for example. We are then able to understand the causes of non-production or non-quality, which allow us to focus our improvement action on the most important problems. We automatically monitor the production process parameters by installing sensors or making better use of existing sensors. We immediately alert operators in the event of a machine failure or quality drift, so that they can intervene quickly and return the machine to its optimal performance as quickly as possible. We use a variety of tools to communicate between the machine and the operator, including smartwatches, smartphones, and other devices. Another example is the continuous monitoring of the energy consumption at our facilities to identify overconsumption, air leaks, or steam leaks. This allows us to reduce our environmental footprint. These are powerful and fairly accessible examples that we are deploying today. They are part of the first lot of applications that allow us to automate the collection of relevant information, facilitate the use of this information, and then organize a rapid response or plan preventive action to optimize our production process. We are already working on the development of more complex applications using more sophisticated sensors such as cameras or laser measurement. The information is then processed by neural networks, artificial intelligence, so that certain stages for our production can be automated. We are also introducing machine learning, which can predict and simulate results and therefore help us with planning. The next step is to predict results and adjust the parameters of a process dynamically, also taking into account supplier data. This helps us to produce good quality from the outset. There are about 80 applications that have been developed since 2017, in the first lot or under development in the second lot. For completeness in relation to our Industry 4.0 roadmap, I should also mention our robotics and flow automation platform and vision system. All this work is possible because of the IT infrastructure we have available. More importantly, it is also due to our plants and the skill they have developed and to our teams in Clermont-Ferrand and in Pune in India. They all contribute to the development of more complex applications for all industrial activities and at the same pace. As an example, we have set up data lakes in our plants. Their installation will be completed by the end of 2021. Data lakes allow us to capture, store, protect, manage, and make available a huge amount of data, including images, for analysis. All the group's plants will have deployed 5 high-priority use cases by the end of the year, enabling them to be autonomous in the deployment of all the 38 use cases from Lot 1. In terms of skills development, we have created in plant position for data analysts, data scientists, data engineers, who will specialize in introducing digital technologies. Today, all the training required to boost the skill of our teams has been developed and is delivered through a group digital academy. Finally, we rely on a robust organization structured around 7 digital leader plants located around the world, all of which have additional resources to develop new concepts and to help the plant in their region to deploy digital manufacturing applications effectively. I hope I share a complete picture with you of digital manufacturing, which is one of the main levers to reach a better industrial efficiency level. Because the picture paints 1,000 words, you can find out more by taking a look at these 6 real-life examples of what we are deploying in our plants. Thank you.